Hello.
Hello.
Hello, Miss Mommy. How are you today?
Good.
Okay. So we talked about the metric a few days ago. Today we're going to talk about implementing the metric multiplication of the power function. So a to the power of n is a times a times a. How many a's times together? And yes, we're done. And what's the time complexity? Oh, because they are n, so oh what? We're done. Okay, so in order for two metrics to multiply together, if they're metric a and b, if we want to multiply a to the metric b, right? We want to multiply together. So the metric, the dimension, if this metric a is dimension of a times b, a rows, b columns, and b metric is c times d. In order for them to be multiplied together, we need to make sure b and c should be the same, yes. So for example, like if this 1, 1, 0, 0, this is 2 times 2 metric. We can times any metric which is 2 rows and any columns, yeah? So it could be 2 times n columns, right? So let's say if we times 2 rows and 3 columns. 2 rows, 3 columns. 1, 2, 3, 4, 5, 6. We can times it together. So how do we do this? We can do this the dot product, yeah? So this row we multiply, we take the rows of the first metric and multiply and do the dot product of the second of the columns of the second metric. So look 1, 0, 1, 4, we do the dot product. So the dot product, what's dot product? If two vectors, yeah, two arrays in vectors, yeah, 2 vectors, we represent it using array. If they are same length, we can multiply together using the dot product. So for example, like a times b equals the sum, yeah, this is 2 metric a and b, not metric, the arrays, the list, the vectors. We do the dot product, so it's a sum of I equals 0 to n minus 1 if there are n elements, yeah, and then we do this ai, the first, the element at index I times bi, and then we sum it together. So for example, if this 1, 0, 1, 4, 1, 0, 1, 4. So the dot product would be 1 times 1 plus 0 times 4, which is 1, right? So 1, 1, 0, 1, 4, and we put it here, which is 1, right? So this the metric. If the metric is the square metric and with all the elements at diagonal is equals to 1 and 0 in the rest of place, we call it identity metric. Yeah? We use the I. So what's identity metric? It's quite similar as the number 1, right? So any metric times the identity metric, it's the same. It won't change, right? So these times that, if you do it, perform it, it will be like 1, 2, 3, 4, 5, 6. And then you reverse it, it's still the same, right? If it's the, can you reverse it? 1, 2, 3, 4, 5, 6. If you times this is what? 2 times 3, right? 2 times 2 rows, 3 columns. And you can't multiply 2 rows, 2 columns, right? You can't do it. So how do we fix this? If it's 2 rows, 3 columns, the metric. Look, this is I, this is A. I times A makes sense, but A times I, we can't multiply it. This I needs to be changed because it's no longer 2 times 2 identity metric. It's 3 times 3 dynamic metric. Yeah, we can just change this to 3 rows, 3 columns. So you'll be multiply. It will be multiply what? It will be multiply 1, 1, 1, 3 times 3 identity metric instead of 2 times 2. Okay? So we talk about how to multiply these n times. But is there a quicker way? Let's talk about the numbers first. If we want to calculate 2 to the power of 100, one way is to multiply this 2. How many times? How many times?
100 times.
100 times, yes, we're done. 2 times 2 times 2, 100 times, yeah? But let's going to take a linear, linear complexities, because this 100, you need to do this 100 times. So a to the power of b to the power of n, if you times the a n times, that's going to take O n times complexity. This is linear. So what's linear? So you can draw a graph. This is n, yeah? And then the vertical axis is the time, the complexity. And if you draw the linear, you'll be like that. Okay? Okay, so now we want to speed it up. So 2 to the power 100, can we divide it? Can we solve the first question, which is, can we compute the 2 to the power of 50 first?
Yes.
Okay, so if we have the 2 to the power of 50, what do we do to get the 2 to the power of 100? How?
Square.
Square, yeah, well done. So 2 to the power of 50, then we can say 2 to the power of 50 times square, right? So what does it mean? If we do this brute force, yeah, do this 100 times. Now, if we do this 50 times, 2 to the power of 50 times, we just need to do it one more time, so 51. So you see, we save almost half of it, right? So look, if we do 50, we can keep continue. 2 to the 50 equals 2 to the power of 25 square, right? And how about 2 to the 25? If it's not an even number, the n is not an even number, how do we do this? If 2 to the 25, what should we do?
2 to the 24 times 2.
2 to the power of 24 times 2, yes. So to sum up, yeah, a to the power of n equals, we can use the big curly brace, equals 2 to a to the power of n minus n divided by 2 and squared if n is even, right? Even number. Or it equals a to the power of n minus 1 times a if n is odd. Okay? So what's the time complexity, if you can remember, see this? Every time we divide this n into half, because we want to solve this, right? If we want to solve this bigger problem, we can solve the half of the problem, and on average we can keep solving the half of problem, we keep dividing into half. So in this case, the time complexity is what? We keep dividing into half, right? We keep dividing into half n times, right? So what's the time complexity of this one? So it's O log base 2n, right? What's log function? Log a to the power of b, ab equals n. Can we write it as a to the power of n equals b, okay? So if we draw this axis, so previously we have this O linear. Linear is O(n). Now log n, how can you draw the log n function? It's like that. Log 2 to the power of 1. So log 2 to the power of 1. 2 to the what equals power 1? 0, right? So 1y, this is y, right? X. So when y is 0, x is what? Log y equals log 2x. So when y is 0, what's the value of x? This is y, this is x. When y is 0, what's the value of x? Look at this.
A.
I know it's a. What's a? What's a? A is 2. A 2 to the power of 0 equals, what's the value of b? 2 to the power of 0, what's this?
1.
1. Okay, so when x is 1, y is 0. So it's here. It's going through here. Look. Pay attention. Okay. Yeah, and then if we drawing, it will be like that. Yeah? So which one is better? So two equivalent, for example, which one is better?
Second one.
Second one. Why is it better? Why is it better? Because look, if x is the size of the problem, right? If we keep increasing the x, the complexity does not grow linear, right? Instead, it will be like that, right? It will be like that. It's reduced, right? So the same, we can do this with the matching multiplication. Okay. So if n is the even number, we divide it, yeah, and then square, yeah. If n is odd number, we reduce by 1. So at the beginning, what should we give to the answer to do it? It's identity, yeah? We give it this identity first. And then we can keep, this is the result, for example, and then, identity for that, and then we times the a, and times a, and by following this pattern, we can reduce it, we can calculate the answer. Yeah? If n is the even number, yeah, we square it. If n is odd number, we times it. Yeah. Okay. So let's write this. Okay. Define with a power. Yeah. Power function. Power metric a n. Right. Okay. So first of all, we need to make sure the number of rows of A and the columns is the same. Yeah. Why is that? Because look, if it's a metric can times itself, if A can times itself, if A is the metric dimension of A rows, B columns, if we need to be able to multiply itself, it's A times B. What does it mean? What does it mean?
A equals B.
A equals B. Okay, A equals B. So A equals B. So let's do this. So look, the number of rows, yeah, rows equals length A. This is getting the rows of the metric, and then columns equals length A0, yeah, because we're getting the first row and then we return the dimension of the rows. So we need to assert. What's assert mean in English? Assert rows equal columns, right? Yeah, and if we want to make sure we can assert these. Assert rows bigger than 0 as well. If it's the empty metric, we don't continue, right? Assert means that to make sure, to double check if the computer finds out the rows and columns are not the same, then the computer will throw an error and refuse to continue. Okay, now we need to create, what's the result of if we multiply the number of rows and the A, what's the dimension or final dimension of A? Is it the same? It's the same, yeah, because the rows and columns are the same. If you multiply it the same, it will be the same. It will be the same dimension. So we create a metric which is called red. Red equals 0 for underscore in range column, yeah. This is the columns, and then for in range rows. So at the beginning, we feel the metric is 0, but we need to find out. We need to initialize the return metric as the identity metric. So what's the identity metric? If this is all 0. So what do we need to do to make it identity metric? What do we need to do to make this metric the identity metric? At the beginning, it's all 0. What's the identity metric? What's identity metric? Remember, we talked about this at the beginning, 5 minutes ago. Yeah, you should remember that. Yeah, look, all the diagonals is 1, all others is 0. So we just need to change this value to 1, right? We just need to change this value to 1. So we use a for loop. Yeah, for are in rows, in range rows. Yeah, we want to iterate from 0 to range rows. And then what should we do? Red R is the rows, and which are the columns? What's the columns? What's the columns? R, the same, yeah. The first row, first column. The second row, second row equals what? 1. Be confident, yeah, you know that, yeah? Okay, so now we have this metric, and then what should we do now? What should we do now? So we need to do this y, we need to check why n is bigger than 0, right? If it's bigger than 0, what should we do? If n 1 bigger than 0, right? If n and 1, what does it mean? If it's an odd number, right? If it's an odd number, so what should we do? We should add red equals multiply. Yeah, we talked about multiply yesterday. Red what? A, yeah, A. And now we multiply it. We need to make the n smaller by half, right? So how do we do it? Shift it by or we can do this A divided by equals 2, or we can shift it one position to the right. Yeah, shift it equals 1, right? And then now when we shift it, we need to double. What do we need? We need to square the A by itself. Yeah, so A equals what? A equals what? Multiply what? Multiply A, yeah. And then return what? Return what? Red. What's the time complexity? We talked about this 3 minutes ago.
Log.
if we talk about log n is times it n times, but we apparently we're not multiplying n times. So let's complexity is log n. Yeah? We talk about 100, reduce to 50, reduce to 35, reduce to 24, reduce to 12, and reduce to what? What's next? 12. What's next?
6.
Yeah, why not? Okay, you're paying attention. Good. Okay, so let's just multiply. Okay, any questions so far?
No.
Okay. Okay. So can you tell me what's identity metric? What's identity metric? Which part is to setting this identity metric? Which part? This part? This part? This part? Which part? This part? Yeah.
Yeah.
Yeah. Okay. And what's this part doing? What's if n1? It's to checking when n is even or odd number. Here.
Yeah.
That's a question. What n is even or odd number? N and 1. If it's an odd number, then we times it 1 time. And what's this doing?
Even number.
Divide by 2. When we reduce 100 to 50, we need to multiply to square a, right? Okay. Okay, that's it for today. Good job. Good job, Miss Mommy. Bye bye.
Okay, bye bye.
Bye bye. Show hand. Bye. Bye. Let people see your hand. Bye.